Hi everybody, welcome back. Well, I've come to the conclusion that Marcel Marceau and I do not share the same gene pool, and because of that I am a really crappy mime, so I'm going to go back to my talking format. And I think a lot of you expressed that you would be happy with that. So for those of you who don't like hearing me prattle on, well, tough crap. You're going to have to hear it. All right. So I don't know why I showed this on the video. I put it right on the camera, and yet I get a bunch of comments. The lead bender that I use to form the leads, that looks like a caliper. What is the part number? So once again, I will put this up on the screen for all of you to feast your eyes upon. There it is. Let me know, maybe you can scan the barcode if I bring it close enough from the screen, if you screenshot it and see if it shows up as anything. But there it is. That is it. Hopefully, like I said, I think I got this on eBay. I think you can still get them. It even comes with a nerdy pocket protector that you can put in, if you want to go all Ward Cleaver or something, you can put that in your shirt pocket. But anyway, there you go. Another thing I want to show you. You all might want to make a screen capture of this. These are a list of substitution transistors that they're ones that I have. There's a lot of other ones you could look up. That these aren't the only ones that'll work, but here's a list of transistors. These are the original ones that were used in the schematic here. All right, in no particular order. So you can see the MPSL01. And again, some of these you can still find, like even on, DigiKey and Mausers and so forth. But some of them are getting harder to find. And some of them, if you do find them, they're new old stock, which is not bad either. But again, if you don't have these things, you don't want to place a special order, here's some other options that I've looked up that should work just fine. And these are the ones that I would probably use. The only caveat I'd put to that is the big output transistors here, the S41775, S41776. If you're going to use any of these that I suggest, use the pairs that are complementary to one another. These are all very, very similar, like the 15022, 21194, 21196, 15024. These are all almost identical transistors, but they each have a mate down here, and I don't think I have them all listed that way. But bottom line is, yeah, maybe I do have them listed like that. You can use those as, just use the complementary pairs is what I'm saying. And I did make sure you read the notes here, because some of these, like for instance, these RCA42C, that letter C is really important. If you use the TIP42C, there is a TIP42A and B, and those both have lower voltage ratings than the C. So make sure you get the correct ones. And I put that in the notes, and you'll see a couple other things. This 2N5415, you can use, one of these. You can still find these. And the 5416s, you can still find those usually. But here's some other ones you can use if you want to use a modern transistor. So for instance, this TTA004B is a really good substitute for these, even though it's a lower voltage. In this particular application, it'll work. Same thing with the MJE350. It's a different case style, but it'll work perfectly. It's actually way higher, better rating than these. So just some ideas. And again, a couple things you have to look out for the pinouts, and you can see here, check pins, check pins, check pins. But if you want to screen capture that, feel free. So in this video, I'm going to replace these transistors. And in an attempt to redeem myself a little bit, we'll do this as a solder and chat. This is probably all I'm going to do in this video because, full disclosure, I have sent all of the chassis pieces, including the base plate that everything mounts to, off to the powder coating place. And they're taking a little extra time this time because they needed to order some new paint or powder coating material that we use special for this. They ran out of it, and they have to order that in, and then they have a pretty heavy caseload of of other projects they're doing for other people. So it might be another week or so, maybe not. In which case, I have a couple other videos I want to throw in there in between this, and so you'll see those too. So we'll do a solder and chat, and like I said, in an attempt to redeem myself because I am a lousy mime. It was fun to try that for a couple videos, but I think the majority of you agree with that, and I agree with all of you, or with those of you who say, better off to talk. It's just who I am. Can't help it. Can't change it. You don't like it? Well, go talk to Marcel Marceau. Well, he's even quieter than he used to be. Never mind. All right, so let's get this out. Somebody did us the favor of desoldering all of these, or at least most of them. This one looks like it might be stuck, but all the rest of them looks like they got loose. So all we have to do is unscrew them. I just got to be careful because these pins stick out here, so I can't really sit this up this way. So we'll have to work on it this direction. And what I'm going to do is I'm going to look up these part numbers if I can to see which ones. You can see these are all Fairchild, and these are the ones that are all shorted. I think almost every one of them in here. There might be one that's not shorted in here when I tested them. These ones are still good, and probably this channel was still good, but you can see there's a lot of crud. They're all going to get replaced. You can see there's some Fairchilds in here and a couple Motorola's. So I do think that at least maybe this side, no, this side does not look like it has ever been serviced. I think this is how it came from the factory. So these are all original. But we're going to replace them with these. Here's what I had in stock. I ordered these a while back when they were still available. I don't even know if you can still get these real easily or not. They come and go. They're still making them, but they seem to be out of them a lot lately. So I had these stowed away, and I have 12 of each, so I definitely have more than enough. I'm going to use the MJ15023 and the MJ15022. So this is the NPN, and this is the PNP. I do have some of these that I have in stock. They're kind of old, but these are the 2N3584 and the 2N6421. Now, there's no reason that I have to use these because there are plenty of ones that are in the TO220 cases like this that you can use, and they'll work just fine. But since I have them, and since this is kind of a special amplifier, I'm going to use them. I'm going to try to keep things at least somewhat original, try to keep the same case sizes and stuff. Same thing with these driver boards. These could easily be replaced with a bunch of TO202 cased transistors, and there's some newer ones that are really good specs that would work in here. But first of all, I don't think any of these would make enough heat that you would really need a heat sink like this. I think that's a little bit overkill on these, but just that would really change this a lot. And I want to keep this the same if I can. This is a hobby, so if I was just trying to bust this out as quickly as possible, I would shotgun all of the components and replace the transistors wholesale. But I think we're going to connect this all up and test it. And if I do need to pull the boards back out, they're really easy to remove, and I'll just go ahead and replace the transistors at that time. And if I replace them on one side, I always have a rule. I keep everything the same and symmetrical, so it looks the same, works the same. If there are any differences, which there probably wouldn't be, but even if there were, they would match on both sides. So there you go. That's our plan. And as you can see, I have a whole bunch of TIP41s and TIP42s, so those are going to be easy. I only need a couple of them, but I've got those installed. Those are really, if you're going to stock up on TO220 transistors, this is a good one to stock up on. These are pretty common. They're very good power ratings, and yeah, I have them in a different bag and all that, but they really work well. So okay, let's start pulling transistors. Okay, so here's the process. Kind of got an assembly line going here. I'm just going to remove the screws, and they're going to be covered with that, you know, zinc or whatever the heck that is that turns yellow and gross. So I'll just use a brush to clean them off a little bit. I am not going to keep the mica pads. I'm just going to throw them out and put new ones on because I hate cleaning them off and all that. I have new ones. I'm just going to use them. And just makes it a lot easier. And yes, I am going to use grease on this and not sill pads because the way these couple together, I think it'd be a lot easier to do it that way. I have some hot water with just a drop of dish soap in it and a toothbrush. And that lets me clean these off. And they actually clean up pretty good. Gets most of the crud off. And then I have a little brush that I've trimmed off because my other one disappeared, the one that I normally use. I don't know where it is. So we'll get this one. And I'm just going to put some compound on there. And the main part you need to get coated is in between the pins. That's where the actual die is. That you know, the actual transistor die itself inside there is right in between those pins. The rest of this metal is literally a heat spreader. So while you want to get it all covered, the most important part is that middle part. I'll pop that on like that. And then I'll put a little bit. You have to get it on both sides because remember, this all has to couple together if it's going to transfer the heat. This is not the ideal way. I mean, this heat tunnel thing that they made is not exactly my favorite. I think somebody commented that NASA, there's a rumor that NASA designed this or something, but where it came from, was inspired from a NASA design, and I'm like, okay, well, not exactly my idea of the best way to do this. I'm a traditionalist. I like the old heat sinks, you know, aluminum. I think I prefer them a little bit over this. So let's put this in here. And the nice thing is these actually aren't, what is it called? These aren't like friction pins. They're just kind of pinned in there. And they're pretty easy to put in there. You don't have to push them in or anything. But when you have fumble fingers like old Tony does here, I just grab them with these big pliers and then I can reach inside there, get those started, just like that. Then I will pop these screws in. Am I in frame? Yeah, I think I am. And we'll put this in here. And I'll get these tightened down before I'll solder them. And then we'll go through and do all of them at once. I just want to get these replaced. And as you can see, I went through on both modules, both halves, and I marked PNP and NPN so I don't have to keep looking up with it because I'll forget. That's just a pain. This one's dead shorted. They all are pretty much on here. So let's do one of these on camera, the whole process from start to finish. How's that sound? I haven't posted it at the time that I'm saying this, but I think I have it uploaded and it's just hasn't been released yet. But I have another video I did on a comment that actually wasn't a comment, it was an email I got from somebody asking, they're setting up their workbench. And they were asking about, actually I had 2 emails from 2 different patrons who were asking me about isolation transformers on the bench and you know, the light bulb, you know, current limiter and how that all works and what I did. So I actually just shot a impromptu video on how mine is built. By no means is it, you know, a one that you should use as a pattern for your own, because it's stuff that I harvested from old X-ray equipment and things. But at least you get the general idea of how these things work. So this is another PNP. So that video will be going up pretty soon here. You'll be seeing it. And for those of you interested in that, might be some good information for you. And like I mentioned, you really do have to take into consideration things like that, especially with test equipment. Quick story while I'm doing this. Long time ago, I was working on an old Raytheon X-ray machine. It was a single phase, line frequency, really old school design. And it had SCRs. It had, I believe it had 2 SCRs. It either had 2 or 4. And they had like opto-isolators that drove the gates. You know, because everything was at 240 volt. And I was pretty new, but I had been trained and I knew better and so forth. But it was one of those things, I was just plugging along and troubleshooting, and I was right on the kind of getting into the actual cause of the problem that I was troubleshooting. So I was real close to figuring it out. And I needed to see if there were drive pulses going into the SCRs. These are big SCRs. I'm talking, they're big stud mounts like that with these big, huge pigtails on them, you know, for wires. And I hooked it up. And I hooked my scope across from ground to the gate terminal, I think it was. As soon as I turned the power on, my probe just exploded. The wire, the ground lead from the probe, vaporized. It just disappeared. And yeah, I forgot. There was, you know, 240 volts on it. And of course, my scope was not floating. It had the ground prong on the plug. A lot of the guys would float their scopes out in the field, the old timers. And, you know, okay, I did it too myself in the past, but that would have just put 240 volts on the chassis of my scope, which probably would have sucked because I wouldn't have thought about it, and that I'd have really got nailed. But that's a really good example of why you need an isolation transformer, because that was 240 volts referenced to ground. This was 30 plus years ago that this happened, but I'll never forget it. It was a lesson learned, and I never made that mistake again. But that's why you kind of have to make sure you're careful with what you do when you work on this stuff, because, you know, not only can you get hurt, you can damage your test equipment. Luckily, the scope survived because the power went straight through the ground, you know, and didn't really get into the scope as per se. Of course, those old Tektronix scopes were so bulletproof. We put those things through and they survived. We all had the 2200 series, like the 2230, 2232, 2220. I had a 2221, which I still have one in mint condition. I don't really use it much, but just kind of for the nostalgia, because that was one of the first semi-digital storage scopes that I ever had. Prior to that, you had the old persistent scopes, and I forget what models those were, but I had one of those too. But and then later they gave me a 2230 and 2232, which I didn't like those because the triggers were so sensitive on them that they would false trigger off of the X-ray machine, and you'd go to take an exposure or hit the prep switch or something, and there was just so much noise that these things generated back then that it would just trigger the scope, and it was really hard to prevent that scope from false triggering. And even with all the little tricks you learned, it still would false trigger on you half the time. And the lower end scopes were actually more reliable. They weren't so sensitive. And even playing around with bandwidth limiting and stuff, the 2230s and 2232s just didn't like the equipment we worked on. But the 2220s, 2211, 2221, they worked really good. Strange, huh? So we ended up, like I said, I basically vaporized the probe, and I had to get another probe. And of course, instead of getting mad, my manager laughed at me when I called and said, you know, what happened. He's like, yep, I remember the first time I did that. I'm glad you have that attitude towards it, because I said, you know, my butt was puckered from that. But anyhow, yeah, that was fun. Good old days. I enjoyed that sort of stuff. Still do. I mean, but, you know, most of that equipment is long gone. You'll never see rooms like that anymore. Everything's so different today. I mean, you know. And it's funny, I went online trying to find some of this equipment, like pictures of it or something, to show some of the younger employees, because I tell them these stories and they're really interested in it. And they'd love to see some of these things, you know, because they're like pieces of history. But as soon as you try to look for this stuff, it's like impossible. Of course, back then, none of us had cameras, or we didn't even have cell phones. I mean, you had a pager and you had a calling card, you know, that you typed your number in, you know, and typed in your PIN number from a payphone if you wanted to call back to the office or something. It was just literally, that's how it was. You know, my first pager just was, it beeped. That's all it did. We didn't even have the numeric readout. And then later on, we got them with the numeric readouts. And then eventually we went to cell phones, but that wasn't until a lot later, you know. So, yeah, things have changed a lot. But of course, it was better back then because no one could bother you when you were out on a service call. You know, back in that time, when you go out on a service call, you know, once you were out in the hospital working on something, nobody bothered you. You were good for 1 or 2 service calls a day. That's it. Now, with cell phones, you're trying to fix things for the customer, and the phone never stops ringing, and everybody expects you to answer right away and get back to them, you know, and you can't even get your job done without 5 other people wanting something. It's just the way things are now. Just how much they've changed over the years. So that's something that I do miss, you know. I wouldn't mind going back to. You know, cell phones and internet and email and text messaging, that stuff is all a mixed blessing, let me tell you. You know, just for every advantage and positive it gives you, there's disadvantages to it, being too available. But it's the times we live in, you got to adjust to it. It is nice, though, to be able to take a picture of something with your cell phone. You know, there were no cell phones, so again, all these things, nobody ever photographed them. Nobody recorded any of this history in the industry that I work. So a lot of these things I tell people about, there's no way to show them. You know, there's very few pictures. You know, there might be some really, really old brochures, but it was such a specialized field that nobody really documented these things very carefully. As a matter of fact, they didn't want to document them. They didn't even want you bringing a camera in the sites because everything was so proprietary. They, you know, with the trade secrets and non-disclosure agreements you had, you couldn't show anything to anybody anyway. So, as a result, nothing got recorded or nothing, you know. So the history's lost. You know, just us telling stories is all that's left. Nowadays, we take pictures of things, and, you know, all my employees have photographs of stuff because, you know, send a picture to someone, hey, have you ever seen this error code before? Or have you ever seen the machine do this before? Or they'll take a little video and text it to you. Man, how easy that makes it. I'd have gave anything for that back then. So that was the good part of it. But the bad part, again, is all the phone calls that you have to take now. So that's why I said sometimes when things get busy, I just don't have time for this hobby. And as a result, I just don't, you know, I can't get down here on a bench, which is okay. You know, just makes it that much more fun when I do get time here on a bench, like now. Clean this off. So you get the point of how I'm going to do this. I'm going to go ahead and do the rest of these, and there's, you know, a whole bunch. I'll get those replaced. When I go to do these ones, I'll show one of those to you too. And then we'll be back. Okay, so I have all of the TO3 outputs replaced with new mica pads and grease and everything cleaned off. So now let's tackle these right here. And I think I'll start with these on the outside. I got to figure out what polarity each one is. I'll have to look up those numbers, and then we'll see what we're going to do to replace them. Okay, even though there's not a ton of information out there, there are some forums, but what it seems to be is any of these transistors, these old ones that have the number 461 as a prefix, those are all going to be PNP, and any of the ones that say 462 are going to be NPN. So this is a 461, so it should be a PNP, which means the N should be the base. So this, I think this goes emitter collector base, so this should be the base. And if I take the meter, kind of back you up a little bit here, so the base should be negative. If I go here, I'm doing it wrong. The base, so it goes base collector emitter, maybe. And watch me play tiddlywinks and flip this across the room. Yep. So there's the emitter, and there's the collector. See, again, different voltages slightly. So this is a good transistor, at least statically it tests out, and it is a PNP. So we are going to replace that with, what is this? A TIP, I think the 41 is the PNP. Make sure it reads the same. Hopefully I'm still in frame. It's kind of weird because all the crap about the video is on my review screen here on the camera if I look through it. Okay, so should be the same thing if it's the correct thing. I can't remember what. Yeah. Okay, so this is wrong. So this is, I need the TIP 42C. And yeah, I could use the little transistor tester thing, but I'm too lazy to get it out. And I could just use a meter. There we go. You all should learn how to use a meter for things so you don't rely on technology for everything all the time, is my opinion. That's just an opinion. But if you learn how to test these things with your meter, instead of just plugging it into some Chinese gizmo that'll tell you everything, you'll understand more about this, and also you'll be able to do a lot with just a meter, and you won't need all those things all the time. Okay, so this is correct, and the pinout is the same, so we're good. So I'm going to go ahead and mount this up there, and I'm probably going to use a sill pad for these just because it's less mess. It'll be just easier. Okay, there's all our transistors, and these two were not shorted. These two were dead shorted. All of the TO3s were bad, and thank goodness the bias transistor is not bad. I'm going to leave that in there because finding a substitute for that one I think would be a little tricky, because it it's a weird number that's hard to cross over. And bias transistors, although you can use different substitutions, a lot of times you may have to modify the potentiometer or one of the resistors or something, especially in these VBE multiplier circuits. Not a hard thing to do, but something I don't want to do unless I have to. So I'm going to leave this in there. It's good. It tested good. I took it out, tested it, put it back in. It's fine. All the rest of them are replaced. And yes, these do have black paint with white stenciling on them. I've seen them like that before. This is a new old stock. It's an original RCA. This one's a Motorola. But they are the correct part numbers, and they should work just fine. 2N6421 for the PNP, and the NPN is a 2N3584. I'm pretty sure I got that correct. So anyway, now to solder them in. That should be relatively easy. And I will just use, I should be able to just use the regular iron on that. I'll get those tacked in there, and I'll be ready to do the other side then. Okay, so this board back here is all done, as you can see. I showed you. And it's time to do this one. And most of these, if not all of these transistors, are good. They're functional. But I am going to replace them so they match the other side. And we don't have to worry about future. Now, this is the part that might be interesting, and that is these have never been desoldered. And the soldering is going to be, we'll see how challenging this is to get these off. Because if you recall on the 2 videos ago, this board was not easy. The solder pads were really hard to heat up, and the plated through holes and everything made this, and the thick copper made it really hard. So we'll see what happens on this one. We'll just do one here without the blower on here, without the fume extractor, and we'll just see. No, that didn't look too bad. So I think we should be able to get these right out. So catch you on the other side here when I get these all cleaned out. Okay, that was surprisingly simple. These ones came out so much easier than the other board. So yeah, very good. I'm happy. So now I'll do the same process to this module as I did to that one over there. And as soon as I get the transistors mounted and get all the heat sinks cleaned, I have a nice fresh bowl of soapy water. So let me get to work. Well, there's the completed amplifier modules, at least as far as I know. I'm pretty sure all of these are going to work. But until we actually test it, we don't know. There might be a couple problems up here in the front end, but I doubt it. I think they're going to be okay. One thing I did notice, it was kind of interesting. I did have at least one good example of each of these TO66 transistors from the originals. Actually, I think the NPNs were both good. The PNPs, one of them was dead shorted. The other one on the other amp module that wasn't damaged was still good. And I did notice in both of the good, I think they were the PNP transistors, the NPNs, I think. The gain on them was extremely high. It was like 379 or 479 or something like that for a beta. On both transistors, the original ones. But on the one good, what was it, PNP transistor I had, or NPN, I forget which one, it had a low beta of, around 47, which is what I would expect, around 50 for a power transistors usually have lower gain like that. Now, these, both of them, the NPN and the PNP on the new ones, all had gains of around 47 to 50, which is more in line with what I expected. Again, that doesn't really matter. The point that I'm making is when you have complementary transistors like that, it is not uncommon for one polarity transistor to have a much higher gain than the other. That happens sometimes. It's not a big deal because of the way that they're used in the circuit. And I'm just saying that, you know, kind of because I get a lot of comments about that people worry about gain matching their output transistors or the big driver transistors, whatever. Not a big deal. So anyway, amplifiers are done. This is cleaned up. I'm going to put these together and assemble the modules. And I think we'll be ready to test this out. In the next video, I'm actually going to take the back plate, the rear of the amplifier, and I'm going to replace the fan. We're going to upgrade the soft start circuit with one of these soft start boards and get it ready. And then when the covers and the chassis parts and all that come back from the powder coaters, I'll start assembling and we'll be able to maybe give this thing a first power up test. So that's what's coming up in the future. Until then, I wish you all peace, joy, happiness, and good health in your lives, and we'll see you again real soon. Take care, everybody. Bye-bye.